This is number 12 on the integral test homework. And you can see, for those of you who looked at the video for number 5, this one looks a lot like the one for number 5. But this one is much easier than the one on number 5, all right? Again, if this was mixed in with other integrals, the thing that jumps out at me, the derivative of the inside function is negative 2n, and that's really close to the value that's being multiplied out in front. And that suggests that I should be able to take the integral of the related function, okay? Of course, the related function here would be x e to the negative x squared dx. Remember what the integral test says. It says if this integral converges, the series should converge. If this integral diverges, the series should diverge. By the way, you should check if you graph this over this interval, this is a positive decreasing, it's called a monotonic function. It's continuously going downhill over the interval that you're looking at. You technically should check that first, otherwise none of what I'm getting ready to tell you works. Anyway though, but the big giveaway for me is, hey, I can take the integral of this, okay? Remember, you can do this if you're somebody who's not in my class watching this on the internet. You'd probably use a U substitution here. In my class, we're just going to look at this and say, hey, the derivative of the inside function is negative 2x, okay? I have an x, the x, okay? But I need a negative 2, okay? So if I'm going to multiply in a negative 2, I'm going to need to balance it by dividing by negative 2 and, of course, factoring that out. Okay, you reverse the chain rule, the derivative of the inside function goes away, okay? The antiderivative here is just negative 1/2 e to the negative x squared, okay? You're evaluating this between 1 and infinity. Remember, infinity is not really a number, so you're really going to take the limit of this as some other variable that you put in there approaches infinity, okay? Negative exponents are terrible for evaluating limits. Don't use them in these situations, all right? Kick this stuff downstairs, okay? It's going to be negative 1 over 2 e to the positive x squared, okay? Use that to evaluate, all right? And anyway, we can substitute b in here. We're going to end up having the limit as b approaches infinity. And again, if you're showing this on a free response in the AP exam, don't drop your limit, okay, until you've actually evaluated the limit. Make sure you're recopying the fact that you need to take a limit. Substituting b in here, that'd be negative 1 over 2 e to the b squared, minus, substituting 1 into this, that's going to be negative, and be careful there, you've got minus negative. You've got 2e to the first power, that's just 2e, okay? Again, if you take this limit, denominator is going to go to infinity. Negative 1 over infinity, this whole thing's going to approach 0. You're subtracting 1 over 2e, and negative 1 over 2e, which means you're adding 1 over 2e. And so anyway, as a result, the integral there is going to approach 1 over 2e, all right? The big thing is that integral converges, which means that the series also converges, okay? And that's how you can use the integral test and, in this case, some improper integrals to show that.